Hi, another update on this 65-inch LG 4K TV. Turns out it's a 3D TV. One of those newfangled 3D pieces of rubbish. I should just put it back in the dumpster, shouldn't I? Anyway, update video on this. People wanted me to do various stuff with it. Didn't have time before. So let's plug in the Etherneties and check this out. We've got some search for EEVblog on Bing, and you end up with some weird looking yank dude who's supposed to be me. I don't get it. Fail. Anyway, yes, the web interface works. Everything's hunky-dory. And yes, I actually got a remote control for it, so I'm not sure if it's the original one for this, but it seems to work just fine. So as you can see, the screen is just fine. I can get into these app thingies here. We've got Netflix, Stan, all that sort of stuff. Now, you see, look, we can get inside Netflix, no problems whatsoever, right? But watch this. Oh, let's watch the Simpsons movie. Well, let's watch the trailer for it and see what happens. Look at that. It normally auto-plays the trailers and stuff like that, but we get that weird mild animated violence, nudity, and drug use. Fantastic. But yeah, as soon as it plays something, it will go to pink. So once it's actually displaying in video content, this is not coming from the HDMI. So clearly, I was wrong about it, or my initial assumption that it was like because I was feeding in HDMI and that was causing the problem. But no, it's not that. So it's definitely not the HDMI input decoder, whatever you want to, that part, that section of the board. There's obviously something where it renders video that actually causes the problem. Apart from that, the TV is the actual screen is absolutely perfect. And this is a bit freaky, but let's watch the video of this TV. Let's go. Once again, it displays all the app stuff absolutely perfectly, so there's obviously nothing. There it goes, video ad and bloody ads. Got to earn my money, don't I? Unbelievable. I don't see ads on any of my YouTube videos because I've got YouTube Premium. So anyway, I recommend YouTube Premium. But look, there you go. So there you have it. Obviously, when it's displaying any form of video content, it buggers up. So nothing to do with the HDMI input. It does it from any sort of streaming source, because it's going to have like H.264, H.265 like hardware decoders, probably in the main chipset or something like that. But anyway, I was able to acquire the service manual for this thing, so let's take a look. And there's an interesting thing on the back as well, which we'll have a look at. Now, it does actually have a component in and that sort of jazz, but I don't readily have the TRS jack 2-component video. I'll probably have one somewhere, but the lab is a mess. See the lab? There you go, that's the current state of the lab. I'm like standing where the benches used to be, so yeah, it's kind of hard to cobble stuff. Anyway, one of the interesting things is that we've got a RS-232C serial interface for like servicing and remote operation. And as it turns out, the actual manual, not the service manual, but the consumer manual, has all the commands for the RS-232 interface that allows you to remote operate it. Like, you can change channels and switch the power off on and do whatnot. So it's fascinating that they're actually got that sort of stuff in a consumer manual. Wow, very impressed. One thing I am going to do is check for updates. It might be out of date. Just make sure I get the latest one. Check for updates. Checking. Here we go. And if we actually go in here and do a picture test, I don't know what type of picture it's supposed to be, but if we do that, failed. So obviously this is like internally generating that video signal. So obviously some sort of video decoder is failing, but all the on-screen display stuff and anything that runs via app and goes through that sort of path instead of a video decoder is a problem. There we go. Let's call them. Oh, that's the Aussie number. So here we go. We actually have the service manual for this thing, internal use only. Fantastic. This is the exact model that we have, and I'm actually very, very impressed with this. There's actually a lot of stuff in here. Dates from 24. Oh, I see. Look. Check leakage hot circuit test. Nice. All right. So we got the specs and all that sort of jazz. So let's go down here and have a look at what we've got. Now, one of the first things which I didn't know about, see all these like service menus and stuff like that. Here we go. These are actually accessed via a remote control, a dedicated service remote control, which I guess you can buy if you're in the service business. If you have this, the block diagrams, which we'll get into, if you had the IR transmitter, whatever, and you had the codes for it, you could of course send those codes out yourself. I don't know. Everyone says, oh, use your phone. My phone doesn't have an IR transmitter. Then yeah, and you can do like calibration and all sorts of, you know, test the ADCs and DACs and all sorts of stuff. So it's absolutely fantastic. Now what we've got here, the full schematics for this thing, which is absolutely fantastic. All the juicy detail is there. They've got kind of like a troubleshooting process, but it's not really the greatest thing. It mostly just says if this board swap. Here's the checklist, like repair power board and parts, normal, replace inverter or module, but other ones just check and replace main board. It's pretty much all you can do. Is it narrows it down to either it's a panel fault, it's a power supply fault, or it's a main board fault, and that's, you know, pretty much it. So they've got some flow charts which aren't the best, but hey, at least we've got them. 20-point white balance, ADC calibration. There's the remote. What is it? Adjust remote or something like that. So it's basically a service remote control. Neat, huh? I didn't know that. Here you go. CNT is broken. It tells you, you know, abnormal power section and stuff like that. So if you're generating this test signal, which is kind of a weird test signal dotting across in a faded thing, it's kind of weird to have that as a test signal. Anyway, it tells you, you know, abnormal display, abnormal power section, you know, like stuff like that. So anyway, it doesn't have anything specific to the fault we had. So what we're going to look at here is, we know the symptoms now, so we're going to have a look at our block diagram. The block diagram is very handy because this is where we're going to be able to narrow the stuff down. And there's basically sort of like, you know, two major chipsets here. One, confusingly, they're both called H13. So I don't know, is that the main board is called H13? I don't get it. Anyway, one is the LG1154D and the LG1154AN. I presume they're different chips. I don't have it open at the moment. So this is interesting. We know it's not like a HDMI receiver problem, because even the internal generated test pattern generates the video fault. Basically, anytime you play video, that causes the problem. So, but all the on-screen display stuff is fine. So it's got nothing to do with H13 over here. This is our AV, component video, SCART, tuner, all that sort of jazz, okay? So it's clearly not any of that. We can rule out all that. Now, with the 1154D over here, this is like the main processor. It's got everything. It's got the Ethernet in, so when we do the YouTube video, for example, or the Netflix, and we're coming in via the Ethernet LAN, it's going directly into this chip here, and it's doing, we'll have a look down here, we'll come back to this in a second, H13D, here it is. Ethernet comes straight in, it's doing everything internal. Is interest to us here is this video encoder, 1080p, 30 frames per second. It's got a dual core processor in there, and it's got all the sound DSP, and it's got the secure stuff. It's got a 1 meg cache, and then it's got down here, I don't know where the 3D, they've got 2D graphics up here. I love this GPU, Rogue Han. Nice. I assume that's Han Solo. That's terrific. Here's on-screen display generation, for example. H3D, is that like the 3D engine? It probably doesn't seem to do much to do like 3D, to add 3D capability or whatever. It's got JPEG encoders, all that sort of stuff. So you know, one possibility is that the video encoder inside this main chip is actually, you know, there's something wrong with it. But the problem with that is that, you know, a lot of these faults will be hardware related in terms of like a large BGA chips like this. They heat up over long-term heat up, cool down every time you power them up. They cycle. You can get cracked solder joints, dry joints, all that sort of stuff. That's why often everyone just says, oh, just reflow the BGA, you know, all that sort of thing. Or if it's extreme, you reball it. But geez, you have to be pretty desperate to do that. Anyway, yeah, like reflow the chip and stuff like that. The problem with this is that this is all internal on the silicon. So if it was this, like, it kind of doesn't make sense from that physical failure point of view, which is probably the most likely scenario. So unless the silicon's died, like maybe the video encoder section in there has died as part of it, but it doesn't, like, that doesn't seem very likely, quite frankly. So it could be like decoupling for this chip or something is a bit marginal. Well, then why isn't anything else affected? Why is it just the video encoding? So yeah, I don't think it's that. So I suspect if we reflowed that chip, I don't think that's going to help us much. What I think's possibly more likely, let's have a look up here. This just shows HDMI coming in over here like this, and here's our panel output, 120 Hertz, LVDS combo, EPI, don't know, VX1, I don't know what any of those are offhand, but of course LVDS is the low voltage differential signaling, which is goes off to, they've got to have a panel driver there. And if we, sure enough, follow the money down here, look at this. Aha! They got two LVDS paths. OSD on-screen display, which works fine, and FHD, full HD. I presume they've got separate on, like, over a screen overlay paths and separate video paths. So, aha! It could be that the video path is something wrong with that. So reflowing that chip could help. Who knows? It could be the pins for that, for example. So obviously the on-screen display, everything's working, and the apps and things like that. So you're doing web browsing and stuff like that. It's obviously not rendering that to the video engine. So it's probably going via the on-screen display path, because all the apps work fine. You browse the web, you do everything else, you go into your Netflix, it all looks good until it plays that video. I think my money at the moment's got to be on this LVDS Full HD part here. And then V1X, there's an 8-lane thing here and a 2-lane for the OSD. So it could very well, it may not be that path there, it could very well be these lanes here. These, by lanes, it just physically means differential pairs, high-speed data lanes, paths, basically traces, going over. So, you know, so we've got potentially 3 suspect components here. We've got this path here, which could be solder joints this end, perhaps. Let's assume it's a physical fault. Solder joints this end, so this chip, and also this URSA 9 chip over here, whatever that is. And then they've got this one path going off to the panel. So there's obviously nothing wrong with that one path going off to the panel and then going onto the T-con board. A lot of people said, oh, check the ribbon cables and stuff like that. No, this is happening on the board. This is definitely not anything to do further down the pipe. I think it's most likely something to do with this sort of interface here. And this is interesting in that the HDMI input over here comes through the HDMI switch. There's nothing wrong with that. That was my original thought, because I was just testing it with the HDMI. So that was a reasonable first assumption, was that the HDMI input switch, decoder, whatever it is, that would be an issue. A lot of people said, oh, the ESD and stuff like that on the inputs. No, it's got nothing to do with that, because as we've seen, we've proven that even internally generated video signals. So, you know, it goes through a splitter here, and interestingly, it bypasses the main chip here. So if you feed in the HDMI input signal, here it can actually just split right down, jitter cleaner, and it goes straight to U14 down here and shoots it straight out. So the processor doesn't, main processor up here, H13, doesn't do any of that. It just does all your on-screen display stuff and other things that would, you know, it has internal video generation, because that would be for Netflix and YouTube and stuff like that, where it's decoding it from Ethernet, for example, or decoding it from a USB port or a hard drive or whatever it is. So, oh, by the way, for those who want to know about the RS-232 serial interface, unfortunately, it doesn't actually give me any useful information. Somebody said, oh, Control-C when you're booting up to try and avoid, to try and break into it. I can't get that. So I've got it hooked up here. Turn the TV on. Okay, TV's on, and we get nothing. But if we power it off, there we go. And we got something when we powered it off. Emergency remount RO. Sometimes we get some more data than that, but basically that's it. We just get a message when it shuts down. So it's of no help. So we can actually try and find maybe an internal debug thing, because that is very common. But yeah, we could potentially maybe get some additional debug stuff out of it. So let's go to this URSA 9 chip, which was like the main output driver. And we can have a look here. Looks like it's got its own SPI flash. It's got chip configuration stuff. Slave, boot from SPI flash. There's lots of like configuration jumpers and stuff like that. Here we go. Debugging, it's I2C. Yeah, I'm not that keen to get out the scope and do I2C decoding and stuff like that. That, you know, no thanks. I don't see a big value in doing that. But the LGE 7411 is the URSA 9. Once again, it's more like option jumpers is there. The schematic's probably not going to tell us a huge amount. Look at all the power pins. That is a metric buttload of... They're just the VSS. They're just the ground pins. Wow. If you lost a couple, lost a few dozen, it's still not going to be a problem. Anyway, this has its own core power supply. So once again, I don't think it's that, because obviously then it wouldn't, if the power supplies were failed for this chip, you wouldn't be able to get the OSD data coming through. For example. So if I went in and measured those local regulators, I almost guarantee that they're fine. It just wouldn't make sense for it to be a power supply issue on that chip. So I've got a ground. Where's all the power? Oh, over here. Didn't see that. There you go. There's all the power rails. Sweet. Oh, look. Secret squirrel. Only for training and service purposes. It's lucky I'm doing training and servicing. Alright, so I've got the board out. I thought I'd at least have a go at reflowing a chip. Now, I know it's not the highest odds, but this URSA 9 chip up here, it's this puppy right here, and it's already had the heat sink-in pad actually removed from it, stuck to the back of the metal plate on the thing. So, I don't know, maybe that's kind of a, you know, a suspect in its own right, perhaps. Maybe it's, you know, it's gotten too hot or something like that, and the adhesive on the back of that's come off. I don't know. But anyway, this is the, of course, goes out to the LCD panels here. So it's not going to be anything on this side of it, but certainly something coming in, that on-screen display bus coming in, perhaps. Anyway, it's readily available. The other ones, I'm not quite sure where they are, but these seem ridiculously difficult to get off. There's a main chip under here as well, and another one up there. Really, just for pure access sake, I'm just going to have a go at just reflowing this. I'm not going to reflow the whole board. There you go. It's just a couple of bypass caps there. So nothing really doing there at all. So what I'm going to do is actually use my preheater here. It's a Pooey preheater. J8280 for those playing along at home. I got this for like $10 on eBay. It cost more for postage than it did for the actual thing. I got it like an auction. Nobody bid on it. So it's a preheater. So what we're going to do is just heat the bottom of this board, there's multiple layers of ground planes in here. I don't know how many layer board this is, but basically the idea is just to raise the bottom temperature of that so that when we hit it with our hot air gun on top, it's not as big a thermal shock. And there's pros and cons. I know some people don't like using preheaters, other people swear by them, etc., etc. I just thought I'd give it a go. Maybe just, bump it up by 100 degrees, just help it along. So all the stuff I'm going to do here, please do not take this as my recommendation or best practice or anything like that for reflowing or reworking BGAs. I do not do this for a living. I don't really have any major feel for it because I don't do it every day or even every month, stuff like this. So really, I'm just kind of like just sucking and seeing if I can make any difference here. So by all means, leave comments down below about how you reflow BGAs and all that. But, please, look, just, keep it nice, okay? Just got a small amount of preheat under there, 100 degrees C. That's pretty warm. So, yeah, that'll maybe reduce the thermal shock, but I don't want to do too much other damage as well. You've got to be careful with any, as I've done in previous video. Whoop, yeah, I melted the connectors. Previous time I tried to do this controlled in my reflow oven. Anyway, I've got my quick 861DW. I set it for just 400 degrees, nominal maximum airflow. So we'll give it a go. I could have put some capped on tape around here, but anyway, just looking for any movement, maybe help reflow the pins self-center. Of course, there's an art and science to this, and as I said, I don't have a feel for it. This is just me trying to do something, at least, just to see if I can get this chip to reflow and make a difference. If the chip doesn't actually get to 450, there's a lot of loss in the air. It all has to do with airflow and how quickly it can, how efficiently it can transfer that heat and the drop from the element, etc., etc. There's a ton of stuff which goes into this, and I didn't see that chip. Expected to see it sort of like just maybe slightly wobble a bit, and again, you've got to be looking carefully for it. So hopefully those joints get hot enough to reflow, and maybe it'll fix something. Well, unfortunately, that didn't work. I'll spare you the details, but exactly the same problem. It's still, we haven't harmed it. It's still hunky-dory. So the thermal pad for this one actually came off is the infamous U14, which connects everything else. You can actually see the traces actually going up here. These pairs, they jump down to the bottom and go up to there. So, we've kind of sort of tried to reflow that. Whether or not the ball's actually reflowed, not 100% sure. Anyway, this little baby here is central to everything. It's coming from the other main chippity-doo-dah up here, but this one interconnects them all. So this one technically has the highest probability of having an interconnect, i.e. a BGA ball, that is suspect on one of those, not the OSD line, the actual video line. Do the same. Preheat and reflow on that one. And that's the bottom of the chip there. What's there? Once again, there's a couple of bypass casts, but there's really nothing else. Interestingly, there's a flat flex cable connector there. So I only put part of the board on there. Like, there's no point heating up the whole thing. It could fit like lengthways, but then you heat up, and it's got those little rubber bumpers on the bottom. I don't want to melt those or take them off or anything. So just give it a little hand, that's all. Alright, we've got some preheater action on there. Let's give this a go. Max 120 litres per minute airflow. Let's try and heat it up. Hopefully I don't melt those. I should cover those plastic connectors. Should put some tape on those. Famous last words, right? Shoulda, coulda. Trying to find the slightest little movement in that, just to see that it's... Should hopefully it'll... the surface tension of the solder will keep the balls in line. I just want to see some resemblance of movement, but it could be hard to see. Aha! Now this is really interesting. And if you remember the picture before, the squares and it was like pink and it was shimmering all over the place, it is changed. It is now fixed. So something has changed, and I didn't see any change like this when I reheated that output chip, the one that was driving the panel. I didn't see that at all, but heating this one up, it's done something. Ah, ha. And that's the same for Netflix as well. We're definitely onto something, so I might take that board out again. It's just hanging on by a loose thread, and just reheat it again. Maybe I wasn't vigorous enough. Just put some Kapton around there just to protect the connectors there. Hopefully the higher temperature will get the heat through quicker. Hopefully reflow the balls quicker without putting less stress on the chip, but obviously we didn't do any damage last time. This is as high as the quick goes, by the way, 500 degrees and 200 litres per minute. I could like decrease the airflow, you know, but once again, I said I don't have a feel for this, because unless you extensively do this, like every day, every week, you really get a feel for the particular type of gear that you're using, then, well, you know, you're just having a stab like I am. All right, let's give it a bell. Yep, panel still works, so we didn't damage it. And picture test. Nah, same. Bummer. And I found my wider nozzle. And this nozzle's much nicer because your hand doesn't get all the reflected heat coming back. Yeah, it's moving. Whoa, 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 please. Oh, yeah. Okay, I expect a high probability of it not even powering up now. Nah, yeah, completely gone. Damn, that chip is gone ski. Well, it's moved out of alignment. All right, when in doubt, add flux. Could say probably should have used flux to begin with, but I've got this liquid flux here. I have not used it before, so please don't take this as a recommendation, but it's sort of like it's got a brush and it's liquid, so I want to try and get it at least to run down the balls there. So I'll do all four corners, let gravity try and get in there, but there's so little gap between the balls in there, it's going to be hard. Oh, she's bubbling. She's bubbling. Nope. I do believe we've done our dash. We've got some lines on there, not sure if you can see that. Oh, now I've got lines on this half over here. So it seems to be like, yeah, it's just changing all the time. Well, there you go. I think we've come a gutser on this poor little chip. I think it's had maybe a bit too much abuse, and, you know, the thing might have shifted on there. We've probably, like, you know, shorted some balls out, something like that. So that's going to be really hard to get going again unless we actually physically take the whole chip off, clean up the pads and stuff like that. There's, I don't know how many, you know, 500-600 more pins on this thing. Clean up the pads, and maybe some balls have come off, so you might have to re-ball it, and that's not, I don't want to go down that rabbit hole, really. Certainly not in this video. And, like, it's nothing else around it, so I think it is that lane interconnect. We, of course, reflowed this one up here. It wasn't that. Like, they use different memory here to, like, one decodes video, one doesn't. It, you know, it could have potentially have been that, but the fact that we actually got it to change substantially when we reflowed this chip shows that that thing was an issue. So that's most likely our diagnosis was right there. So that was a real bummer, but at least we had a go at reflowing this thing to see if it made a difference. And I hope you enjoyed that troubleshooting procedure. In the end, I believe we guessed the right chip. We sort of, you know, looked at the symptoms, narrowed it all down, and said the highest probability was that chip. And sure enough, when we reflowed that puppy the first time, it actually changed. So there was some difference in there. What that issue you know, did it fix a couple of bad joints that we had on there? I don't know. And I've tried several times since to actually try and get this back to a working state, but unfortunately I can't. Might have another go or two, because it's like, I might as well, right? So I might give it another go. But anyway, I hope you enjoyed. That troubleshooting procedure is valuable to go through and see that chip. So ultimately, it might be a board swap. I'm not going to try and find another board like this and take the chip off, like a dumped board and take the chip off and all that. No. A few more shots at this, see if I can do. If I do, I might just whack a video on the second channel if I get this thing fixed. If not, I hope you enjoyed the troubleshooting procedure, and if you did, give it a big thumbs up, and as always, discuss down below. Catch you next time.